Hey everyone, exercise 31 we're going to take a look at. We're going to take a look at how we can calculate with fractions, right? And it's important to know what a square combined with a root does and what a square combined with a product does. So 3 and root 2 are products and how to work with them. So let's take a look. 3 root 2 squared minus 2 root 5 squared. And I'm going to write down the intermediate step here first, and then from this point onwards you can skip that immediate step. I'm going to show that at D, if you want to, what you could skip. Remember, if I have a square of a product, right, this looks a lot like, for example, this thing. If we have 2a squared, chapter 1, a power of a product means I take both things to that power. So here I would get this. Same thing applies here. So what you get is not only 3 squared, but also root 2 squared. And they indicate that with brackets, so it's clear what you take the root of. In between is a times sign, so that stays there. And here you have the first thing squared times the second thing squared. Both things are squared. What you get is 3 squared is 9 times root 2 squared. A root and a square cancel each other out. So root 2 squared is the same as 2. Minus 2 squared is 4. Root 5 squared, root and a square cancel each other out. So you get 18 minus 20. Remember order of operation, first do the multiplication. And it is negative 2. Okay? This intermediate step here, you don't have to write down, but I would advise you certainly at the start to do it, because then you show me, and you show yourself, by the way, as well, that you understand what you are doing. And if you don't make a arithmetic error, at least I understand how you wanted to apply the rule. For example, if you now do 3 squared is 6, yeah, that's very stupid, you could say, but I know your intentions at least, if you skip this step. Although, if you do it correctly, I would give you full points. Again, it's your safety net. B. 3 root 9 plus 7 root 25. People who have already reviewed the theories of, I think, theory B, may take a look at this and say, well, this has no answer because those are not like roots, so I cannot add them up. It's a bit the same like this, right? If I have 3a plus 7b, I could not simplify this. Those are different roots. But there is a big difference here with those exercises. Because root 9 and root 25 you can just calculate. Because root 9 is just 3. And root 25 is just 5. And remember, there is a times sign in between here, so there's a times sign here as well, now that you calculate the roots. So you get 9 plus 35 is 44. Okay? C. Minus root 5 squared minus 5 squared. Some people are a bit annoyed by what happens with that minus here in front. What I assess it like this. I have a negative, outside my root by the way, 5 squared means negative root 5 times negative root 5. That would make it positive again. If you find it difficult to assess why this becomes positive, what you could say is, well, I don't just have minus here, but I have minus 1 here. And then you would have minus 1 squared times root 5 squared minus 5 squared. And then you see that minus 1 times minus 1 is positive 1, and root 5 squared is just 5. So indeed I find a positive thing here. Again, you don't have to do this, right? You can also assume negative times negative is positive, and then you don't assess this as a minus 1. But the result is the same, you get positive 5. Minus, and this minus sign here is not inside of any brackets, so the minus is just chilling there. And then do 25. 5 squared. 5 times 5 minus there. The answer is minus 20. Okay? And D. And now I'm going to do D without writing down that intermediate step. Let's see if we can do that. So 5 root 2 squared means I square 5 and I square root 2. 5 squared is 25. Root 2 squared, the root and the square cancel each other out. So you can just immediately write down this, if you so prefer. The 3 is outside the bracket, so it's not squared. The root 6 is squared. Root and square cancel each other out. So you have this. You get 50 minus 18 is 32. Okay? E minus 5 root 81 minus, inside of brackets, 3 root 2 squared. Yeah, you can first do the square here and leave this for what it is. I'm immediately going to combine those two things. Root 81 I can calculate. That's just 9. This negative is outside the bracket, so we just leave it there. Inside the brackets, I have to square both things. 3 squared, which is 9. And root 2 squared, root and the square cancel each other out, which is 2. Which gives me negative times positive is negative 45. Minus 9 times 8 is 18. So this is going to be minus 63. Okay? Again, this is a subtraction, right? So I get more negative. And F. And this oftentimes, sometimes I ask this question on the test, or not exactly this question, but something like this, because people who haven't practiced and don't know how the rules work, they take a look at this and say, oh, minus 3 root 2 squared, minus 3 root 2 squared, oh, that is just 0. And that's of course incorrect. Because you get minus 3 squared. Again, let's do it without an intermediate step. Minus 3 squared is minus 3 times minus 3 is 9, positive. Times root 2 squared is 2. Minus 3, which is just chilling outside the brackets. Root 2 squared is 2. And you see, surely this is not 0. This is 18. Minus 6 is 12. And some people just immediately write down 0. Yeah, that's also 0 points, of course. Again, if you want to, you have an intermediate step here that does this, right? Minus 3 squared times root 2 squared. But you don't have to write that down. And then you see that minus 3 squared is 9, because negative times negative is positive. Root 2 squared, the root and the square cancel each other out to become positive 2. Okay, hopefully this helps you out. Good luck.